Hey everyone, we're going to look at the idea of average speed, that is going a distance over a period of time. So the speed we have been calculating is a constant speed over a short period of time. Another name for this is instantaneous speed. If a trip has multiple parts, each part must be treated separately. In this case, we can calculate the average speed for a total trip. Determine the average speed by finding the total distance you traveled and dividing by the total time it took you to travel that distance. Well, seems easy enough. So in physics, we use subscripts. If we look at, say, this, d1, the d refers to distance, but it's a particular distance. It's the distance we travel in the first segment. Okay, T1 is the time it takes to travel that first segment. So the subscript is like the name of the variable, right? It stands for a particular variable. Okay, so don't let subscripts make you nervous. Okay. So average speed and non-uniform motion. The following pattern of steps will help us find the average speed. Find the total distance, which is the sum of the distances traveled in the individual segments of the trip. Find the total time, which is the sum of the times it took to travel those segments. And use the average speed formula, total distance over total time. So if you ride your bike home from school by way of your friend's house, it takes 420 seconds to travel 2,500 meters to his house. You spend 10 minutes there before traveling 3,500 meters to your house in 9 minutes, 540 seconds. What was the average speed for the trip? Well, we're going to use a table or a graphic organizer to tabulate the results. The organizer looks like this. This is the first segment, second segment, third segment, and these are all the distances, all the times, and all the speeds. Okay, let's see what we have. So it takes you 420 seconds, so 420, and this would be 2,500 meters. Notice if we have the units in the heading of the table, we don't have to include them in this particular case. And you spend 10 minutes or 600 seconds there, but you also travel no distance. And then finally returning to your house, it's 540 seconds and 3,500 meters. Okay, so getting the total distance is 6,000 meters, and getting the total time is going to be 1,560 seconds. Okay, and let me just move this over here. 2,500 divided by 420 is about 6.0 meters per second. Well, I hardly have to do this one. It's just going to be 0. And 3,500 divided by 540 is about 6.5 meters per second. So in the last segment, we did go a little faster. Now let's see what the average is. So that would be 6,000 divided by 1560. And that's going to be 3.8 meters per second. Does anybody know why the average using total distance over total time is lower than either of the non-zero average speeds for any of the segments? Well, that's right. It's because that middle 10-minute period, we had no speed at all. So we're actually averaging that with zero, making the overall average speed a lot lower. Okay, let's move along a little bit here. Okay, step one, they start filling in the table. Step two, they have all the distances and all the times filled in, and they get total distance by adding them all up. You get the 6,000, which is what we got. Next, they add up the times. 1560, again what we got. And once they divide, they get 3.85. Notice from before that even if I took the average of these three numbers, it would be different than if I took the ratio of total distance to total time. So we use the constant speed formula to find what's missing for our segments if we need to, and then we calculate average time by summing all those distances and all those times and then dividing distance by time. Okay, fill in the table to determine average speed. Okay, you run a distance of 210 meters at 7 meters per second. Okay, so this is the first segment. So 210 meters at 7 meters per second. Then you jog a distance of 800 meters in 235 seconds. And then you run for 25 seconds at a speed of 6 meters per second. So we're missing time for the first interval. So time is equal to distance over speed. So that's going to be 210 meters over 7 meters per second is 30 seconds. And for the second interval, we would like the speed, which is distance over time. So that's going to be 800 meters over 235 seconds. Which is about 3.4 meters per second. And last but not least, we want distance. So distance is speed times time. And we have 6 meters per second times 25 seconds. Distance is about 150, well actually exactly 150 meters. Okay, and if we get total distance, that's going to be 1,160 meters. Total time, sorry, that's 30 seconds. We'll just use 30. Is going to be 0, 9, and 2, about 290 seconds. And if I want the average speed, That's equal to total distance over total time is 1160 meters over 290 seconds, which turns out to be 4 meters per second. Which, if you take the average of the three speeds from each of the segments, does not come out to 4 meters per second, because the segments are all different lengths of time. The distances are all different segment lengths. Okay, a second example. What happens if you take the average arithmetic mean of the speed for each leg of the trip? Is it the same as the average speed? Well, I've already told you. No, it is not. So let's see what they get. Ooh, they don't get anything. We have to do it. But we can do that. So let's see. 7 plus 3 plus 6 equals, divided by 3 equals. So that's actually 5.3 meters per second, which is not 4. Okay, so to get the average velocity, you have to take total distance and divide by total time. Okay, I hope that makes everything about average speed much clearer.